Welcome back to this channel. In this video, we're going to continue with 6.3 Lee Chatelier principle. Before that, we need to understand the definition for Lee Chatelier principle, and then we will go through the factors that will affect the equilibrium position. Basically, we will looking for the concentration of reactant, pressure of reactant, and also that addition of the inert gas at constant volume and constant pressure, temperature, and also catalyst. Let's look at the definition of Lee Chatelier principle. Basically, if a system is disturbed, the system will oppose to reduce the effect of the disturbance. We start with the simplest factor, which is the catalyst. Basically, catalyst has no effect on the equilibrium position. Then why we add the catalyst? Basically, the purpose of the catalyst is we'd like to lower the activation energy. So once the activation energy is lower, it will cause the rate of reaction increase. Let's proceed with tutorial question 14. Consider the following reaction. Based on this question, positive 30 kJ means endothermic. Endothermic process is a process at where we are going, at where the system is absorb the heat from surrounding. So when the system absorb the heat from surrounding, so this heat will act as reactant. Okay, then now by using the Lee Chatelier principle, state the shift in equilibrium position. So because just now we just discussed about the catalyst, let's look at question A until question D. Which question is related with the catalyst? Yes, very good. It is D. And appropriate catalyst is added to the reaction. So what is the equilibrium position will shift to? So based on just now we say there is no effect on the equilibrium position if catalyst is added. So we can just write down no effect. Question 15. Consider the following reaction. This time we will notice that the delta H is negative value, which refer to released heat to surrounding. So if the heat is released to the surrounding, then the heat will at the product side. So by using the Lee Chatelier principle as well, state the equilibrium position. So means that need to mention left, right, or forward, backward. So again, question 15, A until D, also D is related with the catalyst. So there is no effect for the catalyst on the equilibrium position. Now let's look at how the factor of concentration will affect the equilibrium position. If you increase the concentration of A, system going to oppose by decreasing the concentration of A. So when the concentration of A is decreased, means that the system going to consume the A and A will react as the reactant. Another factor which is quite similar with the factor of the concentration is the partial pressure. However, do keep in mind that the factor of partial pressure only will involve the system consists gas. So if you increase the partial pressure of gas A, system will oppose to reduce the partial pressure of A, and then it need to consume the A, means that A will act as reactant. Now continue with tutorial question number B, which is related with the concentration. If the bromine gas is added to the container, so means that you increase concentration Br2 and system opposed to reduce concentration Br2. So if system reduce the concentration of Br2, system need to consume Br2, and Br2 will act as reactant. So refer back to the equation over here. If the Br2 need to be as reactant, the system have to shift to the left hand side. Question 15b is related with the partial pressure, or we also can consider as the factor of concentration, because when you remove the PCl3 from the container, means that concentration and the partial pressure of PCl3 will be reduced. So then the system will oppose to increase the partial pressure of PCl3 by producing PCl3. So if we need to produce PCl3, means that PCl3 is a product. So based on this equation over here, if the PCl3 is the product, means that the system need to shift to the right. Besides discuss about the effect of partial pressure on the equilibrium position, we also will discuss about total pressure. So when we discuss about the total pressure, we will relate with the volume of the container. Basically, if volume of the container is increased, so the total pressure will be decreased. And then at the same time, don't forget the partial pressure for each gas also will be decreased. So up to here, this is the this is the effect of your action. So even though you increase the volume of the container, but at the same time, actually you are reducing the total pressure. So the system will oppose to increase the total pressure. So and then they will shift to the side with more number of mole of gas, because we know that from the formula PV equal to nRT. If the number of mole of gas increase, the total pressure also will be increased. So let's check again. When the volume of container increase, total pressure of the container decrease, cause each of the partial pressure gas decreasing, and then system need to oppose to increase the pressure by shift to the side with more number of mole of gas. Let's look at tutorial question 16b, which is related with the total pressure. Okay, so we need to read the question first, considering the reaction, and then you are going to decide how will the amount of H2O gas change. Okay, if the volume of the container is decreased, that means this is what you did. You reduce the volume of the container by compress the container, so means that the pressure will be increased. Okay, then system will going to oppose to reduce the pressure. So if system want to reduce the pressure, the system need to go to the side with less number of mole of gas. So when we refer to the equation over here, at the left hand side here, we have one more hydrogen and one more carbon dioxide, means that total have 2 more of gas. While for the right hand side here, we have one more of H2O and also one more of carbon monoxide, so also have 2 more of gas. So in this question, even though based on the Chatelier principle, the equilibrium position supposedly move to the side with less number of mole of gas, but then we have no choice to shift to the left or shift to the right because both sides have same number of mole of the gas. So that's why come out the idea will be no effect. So at the same time, we also notice carbon dioxide gas is removed. This is the effect for the reducing the partial pressure of the CO2, or also we can consider concentration of CO2 is decreasing. Okay, so this is the action done by you. So what the system will do, system will increase the partial pressure of CO2. So if the system want to increase the partial pressure of CO2, means that need to produce CO2. Once need to produce CO2, means CO2 will act as product. So then again, now only we refer to this equation. If CO2 is need to be as the product, the system has to shift to the left. So done for question C as well. Let's look at another factor or action that you may done to check whether the equilibrium position will be affected or no. So the action is adding inert gas. However, when you are adding into the inert gas at a constant volume, okay, so for this one, we will relate with the Dalton's law. In these factors, we are going to relate with the Dalton's law. Let's say initially we have a container. In this container, we have A and B. Okay, so at where the gases of A will become gases of B. So each of them have the partial pressure 1 atm and 2 atm respectively. Okay, so this is a closed container. So the partial pressure of A before the inert gas is added is 1 atm. And partial pressure of B is 2 atm. This is before inert gas is added. So let's say now we already add the inert gas inside, which is the neon, for example. And then neon is a inert gas at where they will not react with gas A and B, which this one is related with the Dalton's law. So if this is the case happen, the partial pressure of A will still remain as 1 atm because we just add the neon gas inside without disturb the volume of the container. Therefore, the partial pressure of A will still remain as 1 atm, okay? Because we use the formula ideal gas equation. Number of mole of A does not change, volume of A does not change, temperature of A also does not change. Therefore, the partial pressure of A confirm also have no changes. So same case happen to the partial pressure of B, 2 atm. They are still remain as 2 atm. And then the neon gas, even though the neon gas, for example, have 3 atm, but neon gas is not involved in the system because they cannot react with the system. So in other words to say, when we add the inert gas at constant volume, partial pressure A in the system will remain unchanged. Other words to say is, the equilibrium system is not disturbed, and that means that even though you add the inert gas, but actually there is no effect on the equilibrium position. Now, let's look at another condition. If I add the inert gas at a constant pressure, So now it's different, okay? Previously, I said in a closed container, we have A 1 atm, B 2 atm. Okay, so again, this is before neon aided. Partial pressure A equal to 1 atm, partial pressure B equal to 2 atm, and total pressure is equal to 3 atm. So after you add in the neon gas, again, let's say the neon gas is 3 atm. So the total pressure now in the container will become 6 atm because partial pressure A maintain 1 atm, partial pressure B 2 atm, partial pressure C 3 atm. Okay, so this is after. However, the requirement of the question here is we need to add the inert gas inside and then we have to maintain the pressure at a constant pressure. Means that from the 6 atm now we need to change them to 3 atm. So what can be done by the system so that the total pressure will equal to 3 atm? So the system have to increase the pressure because from 6 atm to 3 atm means that the partial pressure of the A and also B need to be reduced. So when partial pressure A and partial pressure B is reduced, means that this is the disturbance that making from you. Okay, so partial pressure A will adjust to lower the pressure because the total pressure need to maintain. So system will going to increase the pressure. Okay, when you add the inert gas at constant pressure, you are success to reduce the partial pressure A and B. So that's why now system need to oppose to increase the pressure. So if we want to increase the pressure, if the system want to increase the pressure, so the system have to make sure they move to the side with more number of gases. Now let's identify tutorial question number 14. C is related with what we discussed just now, which is adding the neon gas at constant volume. So based on the conclusion just now, we know that if the inert gas is at constant volume, the partial pressure gas for NOBr, NO, and partial pressure of Br2 in the system are not affected. So once the partial pressure of this reactant and substance are not affected, system is not disturbed. Okay, when the system is not disturbed, so the equilibrium position has no change. Now let's continue with the question C, which is related with the adding the inert gas. But this time we are going to add the inert gas at constant pressure. In other words to say, we know that this action, the action that done by you by adding which you add the neon gas, basically is cause the partial pressure of all the PCl5, partial pressure of PCl3, and partial pressure of Cl2 gas is reduced. Okay, this is done by you because we want to maintain the constant pressure after the neon gas is added. So each of them have to reduce a bit so that the total pressure will remain. So system will going to oppose by increase the pressure. So if system want to increase the pressure, so system have to shift to the side with more number of gas. So let's refer to here. If at the left hand side here we only have one mole of gas, while at the right hand side here we have two more of gas. So if you add the inert gas in the container with constant pressure, the system is going to shift to the right based on the chemical equation given above. The last factor that we are going to discuss in this video is temperature. Temperature not just will affect the equilibrium position, but at the same time, the value of the Kc also will be affected if the temperature is changed. But we just need to know about this. We have no further discuss about how the value of the Kc will be changed. Okay, so now we look at how the temperature will affect the equilibrium position. If you increase the temperature of the system will oppose to decrease the temperature as usual. So how the system decrease the temperature means that the system will shift to the side without heat. So that is why in this question you have to know how to differentiate endothermic and also exothermic process. At where you have to identify first the heat is as the reactant or product. Now look at tutorial question 14a. As just now we already know that when we see that enthalpy change is positive value, means that it is endothermic process, absorb heat, so heat will act as reactant. So now we have to check at first the temperature of the equilibrium is 298 Kelvin, then the reaction is changed to 400 Kelvin. So means that the action done by you is increase the temperature. So system going to reduce the temperature and then have to shift to the side without heat. So if there is no heat, then we have to refer to the side, to the chemical equation over here. So right hand side have no heat, so that's why the equilibrium system is shift to the right. Okay, question 15a, just now identify that the heat is as the product. So this time we try to check again. Initially, the reaction is happen at 298 Kelvin. Then the reaction is changed to 350 Kelvin. So same case as well. You are the one who increase the temperature. So system going to reduce the temperature and going to shift to the side without heat. So again, when we refer to this equation, the side without heat is the left hand side. Question 16a. Even though this question doesn't give us the temperature, but then we can see the action here is increase the temperature. So again, you are the one who increase the temperature. System going to oppose to reduce the temperature. So we'll go to the side without heat. So when which side has no heat, we have to refer to the chemical equation. So the chemical equation is not show the heat inside here. So we have to deduce ourselves using the enthalpy change value. So positive side means endothermic process. So the heat is absorbed from the surrounding. So heat will act as the reactant. So we will place the heat at the right hand side here. Left hand side here. Okay, without the heat, it means that the system will shift to the right. Question 17. Haber process is where ammonia will be produced, and then the reaction here given delta H equal to negative 92 kJ per mole means that this is exothermic. The heat will act as the product, sorry. And then now let's look at tutorial question number 8. What is the common catalyst used for Haber process? Yes, there is no other answer, it's iron. What will happen to the equilibrium position? Catalyst only will increase the rate of reaction, so there is no effect on the equilibrium position. So next one, based on the Chatelier principle, we are going to explain 4 ways to increase the production of ammonia. So ammonia is at the right hand side here, so means that we want to suggest 4 methods at where the equilibrium position going to shift to the right. So basically, we may start from the first factor that we discussed just now, concentration or the product. So if we want to shift to the right hand side here, means that this is we want to produce more ammonia. So if we want to produce more ammonia, then we can remove ammonia. So if we remove the ammonia, the system will oppose to produce more ammonia and shift to the right. So at the same time, then we have to do the opposite action on the reactant, which we're going to add either nitrogen gas and also the hydrogen gas. So that when more nitrogen and hydrogen gas is added by you, system going to reduce the concentration or amount of nitrogen and hydrogen gas by shifting to the right side. The third one, maybe we will discuss about the pressure. Okay, so when we want to discuss about the pressure, we will relate with the volume of the container. So since we want to shift to the right side, here is the less number of mole of gas. Okay, when there has less number of mole of gas, so means that we are going to increase the total pressure. Okay, so if we want to increase the total pressure, means that we're going to reduce the volume of container. So after that, we will discuss about the temperature. When the temperature is increased, the system will shift to the side with no heat. So if no heat means that going to the left hand side. So we have to do another way around because we want the equilibrium position shift to the right. So means that we're going to, you need to decrease the temperature of the system so that the system will oppose to increase the temperature by shift to the side with the heat. So then another one, maybe we'll ask thinking about the add inert gas at constant volume. So just now we already know that if we add inert gas at constant volume, basically the equilibrium position does not affected. So this is not available. And then another one, maybe we'll think of add inert gas at constant pressure. So as we know, if we add inert gas in constant pressure, actually you are reducing the partial pressure. So when the partial pressure is reduced, system going to oppose and increase the pressure. So if want to increase the pressure, system will shift to the side with more gas. So when we look at this here, left hand side have 4 mole of gas and right hand side only have 2 mole of gas. Means that based on here, the system will shift to the left. But at where we want to increase the production of the ammonia, which is the right side, so this one also cannot be accepted. So we only have these 4 answers. So you can choose, okay, so you have no choice. You must use these 4 action. This slide shows you the final answer for tutorial question 14 until 17 and also the objective answer. So we have already complete chapter 6. So in next video, we are going to continue to chapter 7, ionic equilibrium. Thank you for stay with us.